Hello guys, welcome to the second part of synthetic division to find complex zeros. In the previous example, we took a polynomial and we divided it and found a complex solution. So we're going to do the same thing in this one just to kind of see how this one works out. Remember that complex numbers come from taking a negative square root. All right, so I just wanted to emphasize that one more time. How do we get complex numbers? We get a complex number from taking a negative square root. So some number is negative under the square root, like that. That's what you can think of. So let's go ahead and start this example. We are going to start synthetic division. So in my backwards arrow, I'm going to put -6, and then I'm going to put my coefficients 1, 4, -7, and 30. And I'm going to solve, bring down my 1. 1 times -6 is -6. And I'm going to add, that's a -2. -2 times -6 is a positive 12. -7 plus 12 is a positive 5. 5 times -6 is a -30. And my remainder turns out to be 0, which is what I expected. So from this step, we know that our function f of x is equal to, I started with x plus 6, and if I were to multiply it by this answer, which is what it gave me when I divided, x squared minus 2x plus 5, like that, that would give me the original polynomial. So now here we're trying to find the zeros. What makes the function 0? Because the zeros is when the function is equal to 0. One thing I forgot to mention at the beginning is that the degree of this function is 3. So we're looking for 3 roots, whether they're real or complex, because the degree is 3. So we know we're going to have 3 roots using the fundamental theorem of algebra. That's what we're doing. So let's go back to this problem right here. Again, we're trying to say, when is the function equal to 0? So when is x plus 6 equal to 0? And when is x squared minus 2x plus 5 equal to 0? The very first one is easy to solve. -6 minus 6. X equals -6. There's our first 0. Don't forget about this one. A lot of students tend to forget about that one. And then this one, we have to find two numbers that multiply to 5 and add to -2. You can try to factor it using the box method, but there are no two numbers that multiply to 5 and add to -2. So that tells us we got to use the quadratic formula. So I'm going to go ahead and write my quadratic formula. X equals -b plus or minus the square root of b squared minus, make sure you don't forget the minus like I did last time, minus 4 times a times c, all divided by 2 times a. Again, I like to put the parentheses because it gives me, it makes me have less problems, less errors in my mind. So let's go ahead and identify what my a is. My a is 1. My b is -2. Don't forget the negatives. And my c is 5. And with these type of problems, it's very important that you don't make an algebra mistake with the positive or negative, because it just messes you up completely. So this is a b. B is -2. This is a b, which is a -2. This is an a, which is 1. And this is a c, which is 5. And now we're going to solve. A negative and a negative is a positive, plus or minus the square root of a negative times a negative is a positive. -4 times 1 times 5 is -20. All divided by, I forgot to put my a in here, that's a 1. All divided by 2. All right. And so we're going to continue simplifying it. We're going to have 2 plus or minus the square root of -16 over 2. Notice the negative under the square root gives me my complex solution, or my complex 0 because of the negative. So if I have the square root of a negative 16. To get rid of that negative under there, I bring it out as an I, and I'm left with the square root of 16. And the square root of 16 is 4, so I'm left with 4i, 4 imaginary. So I'm going to substitute that into the equation. 2 plus or minus 4i divided by 2. And then remember that we can separate that into two different parts. We can separate that into 2 divided by 2 plus or minus 4i divided by 2, which gives us 2 over 2 is 1. 4 divided by 2 is 2. So plus or minus 2. And then we still have the I up there. So what are our solutions to this problem? Our solutions are going to be x equals, let's not forget about the negative 6 that we found up here from the given factor at the beginning. So we're going to put x equals negative 6. And let's remember that this is two solutions. This is 1 plus 2i and 1 minus 2i. But I'm just going to write it like this. All right. And that is it for this problem. And remember that we said this was, the degree was 3. So we needed to have 3 roots using the fundamental theorem of algebra. And if we look at it, we got 1, 1 plus, and 1 minus. So that is 3 roots. So there is our answers. All right, guys, hope you liked this video. Give me a like and let me know if you have any questions in the comments. Have a good day.